What's good, guys? Welcome back to another video. Today we're going to be going over two separate ideas that are very closely related: mean value theorem and Rolle's theorem. So without further ado, let's get right to it. All right, so first let's start with the mean value theorem that we have basically right here. What the mean value theorem states is as long as there's a function that is differentiable between a and b, and as well as continuous from the points a and b, there must be a point where the average rate of change from a to b is the exact same thing as the derivative of some point c. So what does that mean? It basically means that if I just take the average rate of change between 2 points, let's just say that's this right here, there's got to be some point along this graph within this interval where the derivative or the slope, the instantaneous slope, is the exact same thing as the average slope. That's all it says. Now over here we have Rolle's theorem. And Rolle's theorem basically states that if I have pretty similar something from a to b, but also f of a equals f of b, in other words, the y values are the exact same, there's got to be some point within this parameter right here where the derivative is equal to 0, which makes logical sense because if this thing comes up at some point, it must come down if it's going to hit the y value, which means that I'm going to have a slope of 0. It starts somewhere, goes down, and then comes back up. Well, at some point it has to have a slope of 0. And if it never goes anywhere, well, the slope was 0 anyway. So that's kind of the idea. And now let's give you a couple of examples of actually real world questions that you might have on a test based on both of these. Let's get to it. All right, so first question we're going to do today is actually based on Rolle's theorem, and it reads something like this. It says, consider the function f of x equals 5x squared minus 10x plus 2 on interval -1 to 3. Evaluate this function, and then does Rolle's theorem apply? If it applies, give the c value where c prime is equal to 0. All right, so first things first, we are given f of x is equal to 5x squared minus 10x plus 2. And what I got to do first is I got to make sure that Rolle's theorem even exists. In other words, Rolle's theorem is almost like a special type of the mean value theorem where the y values on the given interval are the exact same. So the interval that I'm provided here is -1 to 3. Also, technically, the next thing I need to do here is see if this is differentiable within this parameter. Well, look at it. It's quadratic. I know for a fact that it's differentiable. So don't even have to worry about that. But now I want to plug in both of these values. So f of -1 is equal to, well, -1 squared is 1. 1 times 5 is 5. -1 times 10 is positive 10. And then plus 2. That equals 17. Okay. F of 3 is the next thing that I got here. Okay. 3 squared is 9 times 5 is 45. 3 times -10, -30, plus 2, which is equal to -45, or 40 minus 30. Whoa. 45 minus 30, sorry, is 15, plus 2 is 17. Look, they're exact same, so that means Rolle's is in play. We're good now. All right, so what's the next step here? Well, now we got to figure out at what point within this interval right here is this thing, or does this thing have a slope of 0? Because that is when it's flat, right? So how do I do that? Well, let me just take the derivative. So if I take the derivative of this, well, the derivative of 5x squared is just 10x. Derivative of -10x is just -10. Derivative of 2 cancels out. And I'm going to set it equal to 0 and solve. So in this case, add 10 to both sides. I get 10x is equal to 10. Divide everything by 10. and I get x equals 1. So in other words, within this parameter right here, whatever this graph looks like, right, at the point x equals 1, there's either some type of dip, either it looks like this or this. In fact, I know for a fact it looks like this, where the derivative is equal to 0. It's like a turning point, or in this case, like an absolute minimum. All right, on to the next one. All right, this one's a similar idea. It says, consider the function f of x equals cosine 4 pi x on the interval blah, 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 negative 3/4 to negative 1/4. Evaluate this function at both points. Does Rolle's theorem apply? And then finally, if so, where at? All right, so let's write it down again. We got f of x is equal to 4, or cosine of 4 pi x. So f of x is equal to what? Cosine of 4 pi x. And at this point, our interval is from negative 3/4 to negative 1/4. All right, well, now I have to even see if Rolle's theorem works in this case. So, well, I'm going to plug these values in. So, f of negative 3/4 is equal to cosine of 4 pi times negative 3/4. We'll look right here. These are going to cancel out, leaving you with cosine of negative 3 pi. And at this point, I'm just trying to figure out what cosine is at negative 3 pi. Well, I'm trying to think. Doesn't really matter, right? Cosine's even, so negative 3 pi is 3 pi, same exact thing. And well, that is just going to be basically one full rotation all the way around, because 2 pi is one full rotation, and then one more. Leaving me over here, what is my x value over here in the unit circle? Negative 1. So I know that this whole thing is equal to negative 1. All right, round 1 complete. Now I got to do the same thing for the other one. So f of negative 1/4 is equal to cosine of 4 pi times negative 1/4. Well, this is, again, these cancel out, so this is equal to the cosine of just negative pi. And well, this does bring us to the exact same point, because negative pi, well, that's pi. What is cosine at pi? Again, negative 1. So in other words, Rolle's theorem is in play. All right. So now, next thing we're going to have to do here is differentiate. So let's see here. I'm going to have to differentiate this thing with respect to whatever is going on right here. All right. Well, what's the derivative of cosine? Well, that's negative sine. And notice there's an x value inside as well. So this is chain rule. Derivative of 4 pi x, just 4 pi. And that's the derivative right there. Well, what do I have to do now? Well, what I have to do now is set this equal to 0. So negative 4 pi sine 4 pi x is equal to 0. Well, I'm going to divide both sides by 4 pi. Negative 4 pi. Well, 0 divided by anything ends up equaling 0. So this actually just essentially just erases that part here. All right. So next thing I got to do here is I got to think about, when is 4 pi x, or sine of 4 pi x, equal to 0? Well, if we think about the unit circle, sine, when's y value equal to 0? That's going to be my x-intercept. So in other words, at pi. So 4 pi k is equal to pi k. And I didn't mean 4 pi k. Sorry, I meant 4 pi x. Got a little bit ahead of myself there. And now what I'm going to do is I'm going to divide everything by 4 pi. And notice I get x is equal to k over 4. Beautiful. Well, what do I do next here? Well, what I do next is it's got to be on this interval. The thing with sine, cosine, and all these is there's an infinite amount of answers, right? Every rotation, there is the same answer. So what I got to do is I got to basically put this thing within its correct interval. So I'm actually going to move this way now. I know that this thing is negative 3 over 4. It's got to be greater than or equal to, I think I had k over 4, less than or equal to negative 1 over 4. All right, well, what am I going to do next? Well, what I'm going to do is I'm going to multiply everything by 4 since this is all 4 values, and I want to get rid, or I want to isolate k. So that gives me negative 3 is greater than or equal to k, less than or equal to negative 1. And so now I got to think about what k is. Well, in this case, k has got to be an integer, right? In this case, it's going to have to be negative 2, because that's the value between negative 3 and negative 1. So then k, in this case, is equal to negative 4. And if k is equal to negative 1, 4, remember it was negative, or it was k over 4 was what we found. So in this case, actually not negative 4, I'm tripping. Negative 2, because it has to be between negative 3 and negative 1. And that puts us, well, it's k over 4. So that means that the value that we have is negative 1/2. All right. Now the question is like, why does it have to be an integer, right? Why can't it be 1.5 or anything like that? Well, remember, it's got to end up getting plugged in here, and this has got to be some type of pi value. The whole point is that this has to be pi. The reason why is because the sign has to equal 0. Well, sign only equals 0 on the unit circle at 2 points. It's here and here. And at both of those points, you're just having a solid pi number, right? Here's pi, here's technically 2 pi. Any of those values are going to be in between, right? So if I do anything other than negative 2 in this case here, well, if that's the case, when I plug it back in, I'm going to get a value on the inside that's something other than a pi value, making it not equal to 0, so it doesn't correspond, right? It's got to equal pi, so that means it has to be an integer. So when I plug it in here, I know that the value in here is just going to be pi. So that's the reason why. That's the answer. All right, moving on. All right, so the next two questions that we're going to be doing is not Rolle's theorem anymore, but mean value theorem. So the difference between Rolle's theorem and mean value theorem when it comes to solving is Rolle's theorem, you have to check and make sure that the y values are the same. When it comes to mean value theorem, however, it don't matter, right? All I actually worry about in this case isn't that the y values are the same. All I need to know is I just need to know the average rate of change and then see what that looks like in terms of setting it equal to the derivative and then find that point when they equal. So a little bit of different steps, but the idea is kind of the same. So our question for this is consider the function f of x equals 1 over x on the interval of 1, 11. Find the average or mean slope of the function. And then by mean value theorem, we know there exists a c in the open interval 1, 11 such that f prime of c is equal to this mean slope. Find it. All right, simple enough. So we know that f of x is equal to 1 over x. Okay, and we know that our interval is between 1 and 11. Well, the first thing that I got to do is I got to find the average rate of change. So what I do is I plug in these values in for 1 over x. So 1 over 11 minus 1 over 1, which ends up just equaling 1, over 11 minus 1. This is the average rate of change formula for people that do point slope form or slope intercept form, y2 minus y1 is equal to x2 minus x1. This is the same exact idea, but now we're given the function and we have to plug in our respective x values and find the y values first, which is the reason why I did this. Well, now I just solve. I'm going to rewrite 1 as 11 over 11. 1 minus 11 is negative 10. 11 minus 1 is 10. Anytime you're dividing by a complex fraction, it's the same thing as multiplying by the fraction. Look at this. They cross reduce. And in this case, I get m is equal to, well, negative 1 times 1 is negative 1. 11 times 1 is 11. All right, so now I know that my m value is negative 1/11. Cool. So on to part 2. Next thing I got to do is I got to find the derivative of this thing. The derivative of 1 over x, well, the best way to do this is just rewrite it as negative 1. It's the same thing. It just makes things look a little bit easier. So the derivative here is equal to negative 1 times x to the negative second here, just like that. So in other words, it is equal to negative 1 over x squared. All right, so now what I got to do is I got to find at what point on this function right here is the slope the same as this, right? Again, the derivative doesn't find the slope. It's like a key to find the slope at any point on the graph. So if I set this equal to the slope, it's going to give me the x value that has the same slope as this right here. So in this case, negative 1 over x squared is equal to negative 1 over 11. All right. So now what I'm going to do, I'm going to cross multiply here. 11 times negative 1 is negative 11. X squared times negative 1 is negative x squared. Well, they both have negatives, so let's just cut them both out. And to undo the square, I take the square root of both sides. So I get x is equal to the square root of 11. So in other words, the instantaneous slope and the average slope end up being the exact same thing at this point. X equals the square root of 11. All right, on to that last question for today. All right, last one is another trig calculus type of question. Consider the function f of x equals 2 sine x over 3 on the interval of 0 to 5. Same idea, I'm finding the average rate of change and then finding the mean value theorem. Typical stuff. All right, so f of x is equal to 2 sine x over 3, and we're looking at the interval from 0 to 5. Well, let me find the average rate of change first. In this case, it's going to be 2 sine of 5 over 3 minus 2 sine of 0 over 3, which ends up equaling 0, over 5 minus 0, which ends up just being 5. Well, when is sine equal to 0? Well, sine is equal to 0 and y is equal to 0, so the sine of 0 is 0, and then 2 times 0 is 0. So it ends up being that the slope equals 2/5 sine 5 over 3. All right, so now what we have to do is we have to take the derivative of this thing. Well, the derivative of sine is cosine. 2 cosine x over 3. And then this is chain rule. This is the same thing as x times 1/3. So in other words, times 1/3. So now what I'm going to have to do is I'm going to have to set this equal to this. So in this case, actually, let me move myself over to this side now. Stuff's getting real. I'm getting 2/3 cosine of x over 3 is equal to 2/5 sine of 5/3. Now I gotta solve for x. So first thing I'm gonna do is I'm gonna multiply both sides by 3/2. This is gonna cancel out here. These are gonna cancel out here. So then what I get is cosine of x/3 is equal to 3/5 sine 5/3. All right. Well, now what do I gotta do? Well, now what I gotta do is I gotta take the inverse cosine of everything. Because whenever you take the inverse cosine of cosine, it gives you theta, the value in between, which is what we're trying to find. So now x/3 is equal to the inverse cosine of 3/5 sine 5/3. All right, and now, last but not least, I have to multiply this whole thing by 3. That gives you x is equal to, 3 times cosine inverse of 3/5 sine 5/3. And there's nothing else you could do here, so that's actually the end of the question, with that being your final answer in that case. And that's basically it. Just kind of like a recap, right? Rolle's theorem is just looking for when that derivative is equal to 0, slope is 0. This is when looking for when the average rate of change is equal to the derivative at a particular point within an interval. If you have any questions like this, always feel free to reach out. Put them in the comments. I'll go through questions just like this. If you want some tutoring, head on over to MindLeap Tutor. I'll get you right. But until next time, I'll see y'all. Take care. And as always, peace out.